In this video, we're going to be talking about something called the quadratic formula and why it's important in algebra. Now, before I get into it, I want to start us off with this problem here as our warm-up. Basically, it's asking us to solve for x, so we have to find x. And notice it's a trinomial, and the other side's already set equal to 0 to help us get ready to solve. Now, you might remember anytime we have a trinomial, generally we'll try to solve using factoring. Since that's the easiest way to do it. So if we were to factor, let's write down our two parentheses, and let's think about two numbers that multiply to give us 3, but could add to give us 4. And 3 doesn't have a lot of options. You can only have 3 times 1 to give you 3. So those are going to have to be the numbers that we work with, and we'll put the x's in front. The next thing that I notice here is that we need a -3. So in order to get a negative number, one of these numbers had to have been negative and one of them has to be positives. But here's the thing, I have to make sure I get a -4. So if I want a -4, both of these needed to be negative. But this doesn't work out because if I were to FOIL this out, I would get x squared, because x times x. -3 plus -1 gives me a -4x, and -3 times 1 is positive 3. So notice how even though we try to factor, it gives us not the same result. This one's a positive 3 and this one's a negative. So I can try again and see if something else works. Maybe x minus 3 and then maybe x plus 1. But then I look at this, like the x times x will give me the x squared, but -3 times positive 1 is -2x, and then -3 times positive 1 is -3. So again, this one doesn't really work out the same way as this one does. So it's like I'm trying to find a factor, but none of them are working because the signs just don't work to make this a -4 and this a -3. So what happens, or what do we do if something's not factorable? So we're given a situation where we've tried to factor and we realize none of the combinations are working. So we have a situation where we don't have something that we can factor, so we can't solve for it or set our factors equal to 0 if it's not factorable. So what do we do next? Well, we could go back to the drawing board and try to graph it in standard form. Like technically this is a standard form equation. We can try to find the vertex and then graph it. But one of the things we need to remember is that graphing is only giving you an estimated solution. It's not going to be very accurate because it's based off your drawing. So today we're going to learn this special formula called the quadratic formula. And this is a formula you can use in any situation when you're given a quadratic equation. And I'm going to show you how to use it. So it's pretty easy to use as long as your quadratic equation is in standard form. So that being said, when you have something in standard form, it has like x squared, then x, and then the constant in that order. And then the other side needs to be set equal to 0. So when you use the quadratic formula, it must be in standard form. So that's really important. You'll notice with this formula here that's in the red box, it's using the coefficients in front of the x. So the a, the b, and then the constant. So those coefficients are going to be plugged into the formula. So you can see the b gets plugged in first, and then the b is squared inside the root. And you have an a and c inside, and a also gets plugged in the bottom. Now, you might be wondering, okay, what is this plus sign again? And notice that this is just that plus and minus sign we were talking about in the last journal. So we mentioned that anytime you have a plus and minus is usually when you have a square root. So when you take a square root, you always have a plus and minus. So that's why the plus and minus is there in the formula. Also, I just want to give you a reminder that quadratics generally have two answers or two solutions for x. So you're going to need to add with this formula and also subtract with this formula. That's why the plus and minus is there. And I'll demonstrate this in an example. So I also want to show you a way you can remember the quadratic formula because this is a formula that you need to know usually because it comes up in a lot of math classes, and also it's used a lot in the ACT or SAT problems. And usually they don't give you the formula. So a lot of students memorize the formula by remembering the song Pop Goes the Weasel. And it goes like this: x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so that's a quick way to remember the quadratic formula, is to sing the song Pop Goes the Weasel. And I know it sounds kind of silly, but it's a classic way to remember the quadratic formula, and I've been using it for years. And I still have this song down, and I remember the formula every time I sing it. All right, so we're going to start by applying this quadratic formula. So one of the things when you're given a quadratic equation, if you want to use the formula, you need to make sure it's in standard form. So when you take a look at this equation, notice how it's not quite in standard form because there's a constant right here. And we want to make sure that the right-hand side is 0. So what we're going to do is move the 7 over, so that way we can make it in standard form, but also that way we can have the right side be 0. So this is going to be 4x squared plus 3x minus 7, because I have to subtract 7 to the other side as well. And 7 doesn't really combine with anything since it's a constant. So I bring all my numbers down, and now I can see what is in front of my x squared, my x, and my constant. So now I know which one is A, B, and C. So I can see my A is 4, my B is 3, and my C is negative 7. So from here, I can just plug in these numbers into the formula and then work it out to simplify. Now, for example 1, it just says to set up, so it doesn't really want us to find the answer. It just says to set up. So we'll just set this up for now, and then maybe later on practice solving. So just practicing the Pop Goes the Weasel song and seeing how we would apply it here. So the song goes like this: x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so you can see I sing the song just to help me remember what the formula is, even though it's right there. But in this case, just seeing how I would plug in things next, it would look like x equals my negative b. My b here is a 3, so this is going to be negative 3 that goes in, plus or minus the square root of b squared. So again, the 3 goes in and it's being squared. So I'm going to put some parentheses around and put a square. Minus 4ac. My a here is 4 and my c is negative 7. So my a is 4, c is negative 7. So I plug those in and it's all over 2a, and a here is 4. So once I have everything plugged in, I would try to simplify this down the best that I can. One of the things that people usually do is work inside the square root first and simplify that using order of operation. And then once they take the square root of the number, they'll try to combine it with the number that's to the side, so the b value. And then at the very last part, they'll divide. All right, so let's do that problem that we couldn't factor. So in example 2, notice this is the exact same problem in the warm-up, but now we get to use the quadratic formula. So I'm going to take it step by step, and we're going to finally figure out what x is using the quadratic formula. So here's the advantage with quadratic formula. It is great to use because all you have to do is make sure that you put a quadratic equation in standard form. So make sure it's in, ax squared, bx, and c format, and then the right side is 0. You'll plug in your coefficients, and then you'll just simplify. The only caveat with, or the con with quadratic formula is the formula is kind of long. So it takes a little bit of time, but it's always bulletproof when it comes to solving a quadratic equation. All right, let's get started. So in this situation, the right side is already 0 for us. So what we're going to do is look at our coefficient here. So for my a here, it looks like I have a 1 in front of my x. So my a here is 1. My b is -4, and my c is -3. So I've grabbed the coefficients in front and labeled my a, b, and c. So I recommend doing this, especially if you're a beginner. And once we have our constants, we're going to plug it into our formula here. So I'm just going to scoot out a little bit to kind of see my formula again that I've written. So x equals -b, and my b here is a -4. So notice that I'm plugging in already a -4. So there's two negatives. The formula has a negative, and this b has a negative. So that's going to change into a positive. So be aware of that. Plus or minus the square root, b squared, so my b here again is that -4. So I'm squaring it and multiplying it by 4ac. So a here in our formula and c is 1 and -3. So 1 and -3 go inside the root. And now I'm going to divide this by 2a. So the formula has 2a on the bottom. My a here is 1. And oftentimes the a is 1 just because oftentimes x squared just has a 1 in front. But that's not always the case, so let's make sure we know how to work this out. So two negatives again on the top is a +4. So what I'm about to do is just simplify the top as best as I can. Maybe I will get rid of the negative since there are two negatives. I'll bring down the plus and minus, and I'll clean up this root. So inside the root, I have a square and a lot of negative signs. So the first thing I'm going to do is do the exponent, because order of operations says, in this case, do the exponents first. So -4 squared gives me +16. Now, when it comes to the other terms beside it, what I would do is look at how many negative signs you have. You have 1, 2, 2 negative signs. So when you multiply all these numbers out, you're going to get a positive sign. So take care of your signs first. I feel like that helps students so much to stay organized. So once you notice there are two negatives, make your sign positive, and then multiply the numbers. So just multiply the numbers, forget about the signs. So 4 times 1 is 4. 4 times 3 is 12. So this is going to be a +12 here. So just a reiteration, when you're multiplying numbers, look at how many signs there are first, negative signs, and then determine if you need a positive or a negative. We needed a positive since there were two negative signs, and then just multiply the integers. So the 4 times 1 and 3 without the signs. And then the bottom here looks like 2 times 1, which is just a 2 on the bottom. So I've cleaned up the root quite a bit. What I'm going to do now is add the numbers up in the root, and maybe I'll be able to take care of the root or simplify it. So 16 plus 12 inside this root is going to be, let's see, 28. So from here, I've cleaned up quite a bit on my square root, but the square root of 28 is not a clean answer. And so it looks like I'm almost like done simplifying. But I realize, the square root of 28, we can take the square root of that. We've done that before. So if something's not a perfect square root, we use a factor tree. So if we break down 28, it's 4 and 7, and 4 breaks down into 2 and 2. So it looks like I get a pair of 2's that come out, and I have a leftover 7. So these were my prime numbers, but 2 came out as a pair, and 7 has to go back inside the root. So I can replace this with, so 4 plus and minus, I'm going to replace the square root of 28 with 2 square root of 7, and then I'm dividing by 2. So from here, because I was able to bring out that 2, because I'm dividing by 2, I can try to reduce both of these numbers down. So I'm going to bring down this x here, because remember all of these are x's. I'm just bringing it down to see what I have. So x equals, let's see, I'm going to take both tops and divide it by 2. So if you divide 4 by 2, you get 2. If you divide 2 with 2, this ends up just being 1 square root of 7. But a lot of people don't write the 1 in front because it's a little bit redundant. So they might just erase that and just write square root of 7. So what I did was I divided the 4 by 2 and I divided by the 2 by 2. So whenever you have a fraction, make sure you divide both terms by 2 is what we just did. And there we go. It looks like x equals 2 square root of 7 and x equals 2 minus square root of 7. So there are 2 answers here. And you can probably now see why this was so difficult to factor. Like getting a square root of 7 would have been impossible to see that that was the factor that would result to be. In the next video, we'll continue practicing using the quadratic formula to solve x for quadratic equations. So stay tuned for that video. Bye guys!